In this video, we're going to look at circles, and it says, given the equation of a circle not in standard form, determine the standard form by completing the square. So we need to write down what the standard form for a circle is. And you can kind of see the standard form here from these options, but the standard form would be x minus h squared plus y minus k squared is equal to r squared. And so we need to basically factor all the x terms and all the y terms into these perfect squares. And then we need to move our constant value over to the right side, and that will be our r squared value. So to do that, let's first start by dividing everything here by 2, because I can see that they're all even, and then we have it equal to 0. So if I divide everything by 2, I end up with x squared plus 4x plus y squared plus 8y minus 5 equals 0. Now I'm going to move this 5 to the right side, so I get x squared plus 4x, and I'm going to just throw in here that this is going to be plus blank plus y squared plus 8y plus blank equals 5. So I put these blanks in here because I'm going to use completing the square for this next step. And to complete the square, what you do is you take the middle term, so you take b, you divide it by 2, and then you square it, and whatever you get here is the number that you throw into the ending part of your trinomial to help create the perfect square. But if you throw it in on this side, we're going to actually have to throw it in on this side as well. So I'm going to put plus blank here. Now, to figure this out, remember that quadratics are written ax squared plus bx plus c. So this 4 here is actually b, and this 8 here is actually b. So what we'll do first is we'll say that we're going to take 4, we're going to divide it by 2. So that's the b term divided by 2, and then we're going to square it. When we do that, that's 2 squared, which is 4. So I'll put a plus 4 here. And to make sure that I don't change the equation, I'm going to add 4 here. So I still have the same, I could subtract that 4 right back out and be right at the same step. So I still have not changed the original equation. Now I'm going to take 8 divided by 2, and I'm going to square it. And when I do that, 8 divided by 2 is 4. Squared is 16, so I'm going to add a 16 here. So I add a 16 here. And again, same thing applies. I have the same equation. I could subtract the 16 out and the 4 out, and I'd be in the exact same spot I was before. Now, you'll notice that this is a perfect square trinomial, and that this factors to x plus 2 times x plus 2. So we've got equals here. And then this would be plus y plus, see, it factors to another perfect square. This would be x plus, or y plus 4 times y plus 4 is equal to 5 plus 4 is 9, plus 16 is 25. So now I have x plus 2, right? Two things being multiplied like bases, that's x plus 2 squared plus y plus 4 squared equals 25. So you can see now that we have this written in standard form. Now we can actually go a little farther. Our r value, our radius for this circle, we know that r squared is 25. Okay, so this was our solution. This is just extra information, so I'll just write extra. R squared is 25, so r is 5. Our radius of the circle is 5. And this would be our x value and our y value. And remember, the formula has minus for both of those values. Or sorry, this is our h value, also x value, and our k value, y value. But they're opposite signed. So I would have to say that the h value is -2 and the k value is -4. So my center is -2, -4, and my radius is 5. And we use completing the square to do that. Let's try another example. In this example, you can see it's similar to the last one. We are going to start by looking at the leading coefficients. They're all divisible by 2, so we're going to divide all of these by 2 again. And we'll get x squared plus 6x plus y squared plus 4y minus 12 equal 0. And then we're going to rewrite that the standard form would be x minus h squared plus y minus k squared equals r squared. So we're going to have to complete the square on this problem to factor these two things down to perfect squares. The first thing I'll do is move the 12 over, and as I do that, I'm going to put these blanks in here, just like I did in the previous problem, for the piece that I have to add in to complete the square here. So I added 12 to the other side, and then just put these blanks in here. And I'm going to add numbers there, so I have to add numbers on the other side, otherwise it'll change the equation. So to complete the square, we're going to take the b term, remember it's b over 2 squared. So take the b term, we're going to have 6 divided by 2, square it. That's 3 squared, which is 9. So I'll put a 9 in those two spots. 4 divided by 2 squared, it's going to give you 4. So put a 4 here as well. Now this factors to x plus 3 times x plus 3. Plus this factors to y plus 2 times y plus 2. And that all equals, see, 21, 25. So we end up with x plus 3 squared plus y plus 2 squared is equal to 25. And this is our standard form equation. I do notice that they write these as 5 squared there, so you could write 25 as 5 squared. You can see which option we have here. That's the last option. But we can add some extra information. So this is our h term, but it's got to be the opposite sign of what's written here. So we're going to say h is negative 3, k is negative 2, opposite sign there. R is, well, r squared is 25, so r is going to have to be 5. So our center is negative 3, negative 2, with a radius of 5. So that's what we can gather, the information we can gather on the circle equation that we have in standard form.